know. Okay? All right, let's just look at some terminology. Okay. All right, statistics. What is statistics? Just in general, a nice easy definition of statistics is statistics is the science of collecting, summarizing, analyzing, and making inferences from data. So let's talk inferences from data. Now, you are going to find, no matter what you study in university, you're going to take statistics. There's biostatistics, statistics for physics, statistics for engineering. There's business statistics. There's sociology statistics. It pretty much, it doesn't matter what you study. It doesn't matter what you study, you're going to come across it, okay? If some of the best medical people work with statistics, okay? Basically, it's where we take a large number of numbers, a large number of data, and try to make sense out of it. So whether you're, as I said, it doesn't matter what you study. Countless medical studies have been performed to determine the effectiveness of new drugs. They use statistics and statistical methods. Corporations make major business decisions based on statistical analysis. When you're in a corporate meeting, those business people and those CEOs, they're not going to want to know the derivative of something or the integration of something. They want to know the stats. They want to know what's the probability we'll make a profit, etc., etc. That's what they're looking for in those kind of decisions. Again, you know, baseball, football, basketball, batting averages, scoring averages, whatever. Sports have lots of statistics. There's two basic types, descriptive and inferential. We're going to do a little bit of both. Okay? Descriptive statistics, you have pie charts, you have histograms. That's what's used. You have bar graphs. It describes your data. Oh, most of the data lies between this and this, or what, you know, whatever. It just describes where most of your data is. It could be mean, median, and mode, etc. The purpose of descriptive statistics is to summarize or display data to get an answer, to get an eyeball overview of how your data looks, to get an answer. As I said, it uses graphs, tables, charts, averages to help display large amounts of data in compact, understandable form. So we'll talk about that, okay? Inferential statistics, I'm going to start writing up here because inferential statistics uses information that is gathered from a sample to make statements about a population. So, for example, I'll have to get some scrap paper for tomorrow. For example, let's say this represents my population, and let's say my population is all students at York Mills Collegiate. Okay, so let's say this represents all the students at York Mills Collegiate. So I might select a sample, maybe this student, this student, this student, this student. Let's say I have a sample of 4 people. Now, I wouldn't use a sample of 4 people for all the students at York Mills. That is a ridiculously small sample. But the idea is you take your sample and you make decisions or estimations about the population. Right? And we'll talk more about that in the near future. So, we use samples. Inferential statistics uses samples to make statements about a population. So you might say the average salary for male employees across the country was higher than for female based on a random sample. Okay? So the basic difference between the two is descriptive reports only on observations at hand. Inferential statistics makes a statement about the population based on a sample. As soon as you see sample, it's going to be inferential, okay? Because you're using information from a small group of the population to make statements about the population. So let's look at a few examples, and I think you'll see it's not really rocket science. Which of the following groups of data would best be interpreted by descriptive statistics as opposed to inferential? The number of goals each NHL team scored last year. What do you think that is? Is that inferential statistics or descriptive statistics? The number of goals each team made last year. That's more descriptive, right? Plus, I don't see any sample in here, right? An insurance company's record of the number of auto accidents involving their drivers over the age of 70 for the previous 5 years. So they're just trying to find the number of auto accidents for, I guess, the more senior population. Would that be descriptive or inferential? Oh, on the photo. No. Do you have any even numbers? You know what? You know what? I will photocopy this for you. Okay? I'll photocopy this for you. I should have went double. I should have went two side to two side. Okay? I will fix it for you tomorrow. Okay? Even then, I'll photocopy the answers for you. Okay? All right? Don't worry. By tomorrow we'll fix it. Wait, I'm going to just check something here. I know what that was my mistake. Okay. Can you tell me, is this descriptive or inferential? Yeah. There's no mention of a sample here. Now look at this one. Data collected from a sample by a food manufacturer on the average shelf life of one of their products. So this is, they're using a sample, you know it's inferential, right? Data collected from a sample by a drug company on, notice again the word sample, and they're looking at the side effects of one of their cold remedies. So they're using a sample, and samples are used to predict about population. So another way they divide statistics is between one variable statistics and two variable statistics. So one variable statistics, one variable statistics are applied when the distribution of a single factor is needed. So here's some examples. A set of class marks. The lifespans of mass-produced items such as batteries or light bulbs. The heights of players on a basketball team. The sum that results, notice there's just one variable, class marks. Lifespan, height, sum on two cubes, or just when you roll two dice. Daily temperatures, so these are daily temperatures, just one variable, okay? That's single variable statistics. Two variable statistics, I better start writing up here. Two variable statistics, bad spelling, statistics involves two variables, obviously, and are applied to determine the correlation between two variables. All right. For example, just a very simple example. What if I were to do, I'm going to do a little plot of, it'll be, every dot will represent a student. Here I'm going to put number of hours studied, right? Here I'm going to put their mark. Maybe that's not very clear. I'll try again. Mark. This is mark. This is number of hours studied. You would assume that the more a student studies, not always, you would assume that the more the student studies, the higher their mark will be, right? You're trying to see if there's a relationship. There's other factors involved, such as IQ of the student, how efficient their study time is, etc. Okay. So the number of hours, here's some examples. The number of hours students study and their marks on a subsequent exam. The speed by which drivers exceed the speed limit and the amount they are charged on traffic fines. Income and level of education. You would assume that as level of education goes up, their income goes up. Not always, but you would hope. If these dots each represent different individuals, you would hope that your education is paying off. Can I explain anything better? All we've done is the difference between descriptive statistics and inferential statistics, right? And the difference between one variable statistics and two variable. Okay, so we're going to do both. I hope you brought your calculators today. If you could get your calculators ready, that'd be great. Okay, let's talk about variability in data. We talked about inferential statistics, and the sample I choose may be different than the sample you choose, so the data, the information is going to be different from sample to sample. So, variability in data may arise from limited accuracy, variations in the conditions of an experiment, and differences in the sample. So here I am. I would like to determine the average salary of the Red Sox baseball team in the year 2005. In this case, I define my population as all players on the team. In 2005, there were 26 players on the team. Instead of researching all the players on the team, I decided to approximate the average salary by using a sample. So the population had 26 players. Notice sample 1 has 1, 2, 3, 4, 5, 6, 7 players. Sample 2 has 7. Sample 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 players. So they're different samples. Notice, even though they're the same number, they have different people, right? So this is like the samples are different. This is referring to differences in the samples in a survey, okay? Here I picked a larger sample size. So I'm going to describe to you the sampling method that I used. It's called systematic sampling technique. Systematic sampling technique. First of all names, and that's 26 of them, were placed in alphabetical order. Okay? In sample number 1, so I have all the 26 players listed in alphabetical order. In sample number 1, I chose every fourth player beginning with the first name. Okay, sample number 2, just so you can see the differences in how I chose them. I chose every fourth player beginning with the second name. Uh-oh. Sample number 3, I chose every second player beginning with the first name. All right. So let's determine the averages for the each one. Can you guys just pull out your calculators and determine the average? No calculator? Don't think I... It's basically you add them up and divide by the number of players. Anybody got one for number 1? You got one? What no? Anybody got sample number 1? Do you have it? I got something smaller. Did, did you divide by 7? Huh? 5057. I just rounded it to $1. So I got 5,057,403. All you do, you add them up and you divide by 1, 2, 3, 4, 5, 6, 7. You just sum it up, divide by 7. Did anybody get number 2? No. I got 5,081,875. Is that what you got? Oh, okay. I must have. I'm not hearing well. Okay. And number 3, I'll tell you what I got. I got the average salary to be 77063. So 4,977,063. Notice the variability in the results. Okay, why do we have the differences? Yeah. Is it the well, we have 3 samples, but why does this average differ from that average from that average? Yeah. Well, they each have different people. Yeah, exactly. The samples chosen were different. As we picked different people. Out of these three samples, which one do you think is the better estimation of the population average salary? Why is sample 3 better? But they're all by last name. Oh, okay. So, yeah, it's just the starting point. But I think basically to answer this question, which sample did you feel? It's this one. I agree with your reasoning that this one is the larger sample size, regardless of where the starting point is. The larger the sample, the better the information. Yeah. So sample 3 gives the best information because it has because it has a larger sample size. Just for your information, the actual population mean is 4,625,421. Okay, so notice that that number, sample number 3, is closer to the actual approximation. Can I go over anything? Are we good? Which of the following situations involves more than one variable? The lifespan of a rare breed of cat, is that one variable or two? Huh? It's just one. It's just lifespan. Right? This is one. The number of houses sold per month. How many variables do we have? It's just one. It's just number of houses per month. Just one. The ages of players on the Calgary Flames hockey team. One, right? The amount of alcohol consumption and the incidence of automobile accidents. Two. I think this is our answer. You would think as alcohol consumption increases, accidents increase. You would think. It's a good presumption, but you'd have to test it, right? But there could be other reasons why the number of accidents may increase. Which of the following factors does not cause variability in data from sample to sample? It's from sample to sample, right? Does sample size make a difference? Yeah. Population size? No, it does. We don't. It's the samples we're worried about. Varying conditions? Yes. Especially in experiments, sometimes If the climate's hotter, your reactions might occur more quickly. Accuracy of measurement. Yeah, so our answer is B. Number 4. To determine the average height of students attending a high school, 5 random samples of equal size were selected. So they had 5 samples. We'll call it 1, 2, 3, 4, 5. 5 different samples. The mean height and median height in each of the 5 samples was calculated. Which of the following statements most likely describes the result? So they calculated the mean height. We'll call that H bar. The bar on top is used for mean. And the median height, well, I don't know. There's not a symbol for median. But they calculated the mean and median for each one. For each sample. Okay? Now, which would be more accurate? The mean and median vary from sample to sample? Does that make sense? That makes sense. That one sounds good. The mean and median would be the same for each? No, absolutely not. The mean for all samples may vary, but the median will stay the same? Do you guys know the difference between mean and median? Yeah. Mean is you add them up and divide by the number of items. Median is the middle value. 50% are below the median, 50% are above the median. The mean and median are the same as those of the entire population? No. Looks like A is our answer. Okay. Tomorrow we're going to do a large number of terminology, explain it all, and make sure you understand it. So we'll continue tomorrow, and we'll call it a day. I apologize for those photocopy sheets.